Hello children, today we are going to study practice set 7.4. Area of segment. Here area of segment is known as PXQ. Here the shaded region is given. This is known as a minor segment. PXQ is a minor segment. And the remaining part, this part complete, which is shown white inside the circle, this is known as major segment. Area of this segment and area of this is minor segment and this is remaining major segment. How to calculate the area of the minor segment? Here you see a segment. We write as area of segment PXQ equals to area of sector. Sector you know O dash PXQ. This complete is area of sector minus area of triangle OPQ. OPQ. So it will be the remaining part, that is shaded region shown here. You know area of sector theta upon 360 pi r square. Area of triangle OPQ. You know that in a triangle base into height we take. OP is the radius. Now in triangle OTP sine theta, because theta angle O will be given to us to calculate the area of sector. So PT upon OP. PT upon OP. And what is therefore PT equals to the perpendicular side equals to PT equals to sine theta OP. OP is nothing but radius. So here we take PT equals to R sine theta. Area of triangle OPQ equals to half into base into height. Base will be OQ, that is radii of the circle R only, and PT is R sine theta, what we have calculated above. So area of triangle equals to half of R square into sine theta. Area of segment PQX equals to theta upon 360 into pi r square minus half r square sine theta. Now here what is taken common? R square. So what is left? Pi into theta upon 360 minus sine theta upon 2. Note that we have studied the sine ratios of the acute angles only. Obtuse angles are not applicable. Less than or equal to 90 degree. Theta is less than 90 degree or equal to. Now we will turn to exercise. In the adjoining figure, A is the center of the circle, angle ABC equals to 45 degree. Diagram please see. And AC equals to 7 root 2 centimeter. Find the area of segment BXC. Pi equals to 3.14. So here in triangle ABC, AC equals to AB, radii of the same circle. So base angles are congruent. You know that in triangles, sum of all angle equals to 180 degree. If angle ABC and angle ACB equals to 45, so third angle, that is angle BAC, will be 180 minus 90 degree equals to 90 degree. So this will be the central angle. BAC will be of 90 degree. This will also be 45, 45, 45, 90. Sum of all angles in the triangle equals to 180 degree. So angle BAC will be 90 degree. This is calculated here. Therefore, central angle theta equals to 90 degree. Now, area of segment formula is what? R square in bracket pi theta upon 360 minus sine theta upon 2. So 7 root 2 square into 3.14. Pi value is taken 3.14 into 90 upon 360 minus sine 90 upon 2. Sine 90 is what? 1. So simplifying this, you will get answer equals to 98 multiplied by 0.285 equals to 27.93 centimeter square. The area of the segment BXC is 27.93 centimeter square. Next question. In the adjoining figure, O is the center of the circle. Measure arc PQR. Measure arc is given 60 degree. OP equals to 10 centimeter. Find the area of the shaded region. Shaded region is nothing but the segment PQR. So pi equals to 3.14. Root 3 value is 1.73 only here. Given central and measure of arc PQR equals to 60 degree, radius equals to OP equals to 10 centimeter. To find the area of the shaded region, so central angle POR equals to measure of arc PQR, measure of central angle equals to 60 degree. Now area of segment directly formula we can apply. R is given, theta is known to us, 60 degree, pi is 3.14 and sine theta will be sine 60. Substitute the value here, keep on simplifying, you will get 100 into 0.0908 equals to 9.08. The area of the shaded region is 9.08 centimeter square. Next question. In the adjoining figure, if A is the center of the circle, angle PAR 30 degree, AP equals to 7.5. Find the area of the segment PQR. Pi equals to 3.14. Central angle theta is given as 30 degree. Radius AP is given as 7.5 centimeter. So let solution theta equals to 30 degree. So area of segment, again formula, R square into pi theta upon 360 minus sine theta upon 2. Substitute the values and calculate. You might be knowing, students, in this exercise, calculations are very important. So take care while doing the calculations. So this equals to 7.875 divided by 12. It equals to 0.65625. Therefore, the area of segment PQR is 0.65625 square units. Here you can solve after decimal 3 digit and round up to 2 digit also. Question number 4. In the adjoining figure, if O is the center of the circle, PQ is a chord. Angle POQ equals to 90 degree. Area of the shaded region, that means area of segment, is given 114 centimeter square. Find the radius of the circle where pi equals to 3.14. Central angle 90 degree. Here, instead of giving radius, area of segment is given. We have to find out the radius. So formula remains the same. Area of segment PRQ equals to R square into pi theta upon 360 minus sine theta upon 2. R square value will not be known to us, but instead of that, area of segment PRQ is given. So substitute the values of theta and simplify it. You will come across R square equals to 400. So 100 into 4, R equals to 10 into 2. Square root of 100 is 10, 4 is 2. Taking square root on both the sides. So radius equals to 20 centimeter. The radius of the circle is 20 centimeter. Next problem. A chord PQ of a circle with radius 15 centimeter subtends an angle of 60 degree with the center of the circle. Find the area of the minor as well as the major segment. Pi equals to 3.14. Root 3 equals to 1.73. Radius is 15 centimeter. Central angle theta is 60 degree. To find areas of minor and major segments. So chord PQ subtends angle 60 degree at center. Therefore, theta equals to 60 degree. Area of minor segment equals to R square into pi theta upon 360 minus sin theta upon 2. Substitute the values here. You will get area of minor segment equals to 225 into 0.0908 equals to, round up to 20.43 centimeter square. Area of minor segment is 20.43 centimeter square. Area of circle, pi r square, 3.14 into 15 into 15. Answer comes to 706.5 centimeter square. Area of major segment equals to area of circle minus area of minor segment equals to 706.5 minus 20.43 equals to 686.07 centimeter square. Area of major segment equals to 686.07 centimeter square. Therefore, the area of minor segment is 20.43 centimeter square and area of major segment is 686.07 centimeter square. This much is sufficient for this exercise. In the next video, we are going to study problem set 7, the last exercise of our syllabus. So till then, goodbye, take care of yourself. Thank you and have a nice day.